Okay, good evening, everyone, or good morning from wherever you are joining. We're very privileged to have Professor Piyush Anand with us. Just quickly, briefly introduce him. Piyush Anand is an assistant professor of marketing at Rice University. His research examines how computer vision, natural language processing, and machine learning methods can enrich managers and regulators' understanding of consumer and firm behavior. Uh, Piyush obtained his PhD from Cornell University, PGDM from IIM Ahmedabad, and a B.Tech in mechanical engineering from IIT Guwahati. So he's our own alum, and it's really awesome that he accepted our invite. And it's really great to have you, Piyush, with us. Thank you so very much once again. And without further ado, I'll hand it over to you.
Thank you, Anuj, for that kind introduction and the invitation. And hello, everyone. Please feel free to ask questions if you have during the talk in the chat, or you can also reach out to me via email. It's such a pleasure to be here. I fondly remember my time at Ahmedabad as a PGP student. So it's great to be back to share my research with you today. Uh, this is a project that I started during the final year of my PhD at Cornell University, where I was fortunate to pick up skills in machine learning and have access to outstanding research and learning opportunities with the Excellent CS department and business school. So uh, if you're a student considering pursuing a marketing PhD, I would highly suggest considering exploring the Cornell PhD program. So in this paper, uh, this is joint with Dinesh Puranam at University of Southern California and Vrinda Kadiali at Cornell University. In this paper, we explore the nature of vaccine discussions on Twitter to examine if there was polarization in these discussions with COVID. So to give a brief motivation, uh, uh, vaccine hesitancy is a big problem. In 2019, the World Health Organization identified this as one of the top 10 threats to global health. And this is present across countries. 2022 study notes that vaccine hesitancy, the global average is about 28%, with 22% hesitancy in India and 33% in the United States as of June 2021. And for regulators, this is important because vaccine attitudes matter. A recent study from a leading institutional survey, Kaiser Family Foundation, found that just in the US alone, in the last 1 year, about 234,000 deaths could have been avoided, could have been prevented with vaccinations. So this is an important challenge for regulators. And an issue with vaccine inclination is polarization. So what's alarming to regulators is that vaccine hesitancy in the US is fueled by political polarization. Polarization is of key concern to democracies, and especially polarization based on alternative facts or infodemics, which can be harder to undo uh, and gain general acceptance with the general public. So there are other dimensions of polarization as well, such as urban, rural, or even on education levels. But in our context, we look at political polarization in the US context. Right? So we look at vaccine discussions on Twitter. Twitter is the de facto town square for people to share their opinions. Research has found that information shared on Twitter is as fast, if not fastest, compared to other social media. And interestingly, there's also the phenomenon of homophily, which is users tend to cluster based on their opinions. So changing opinions might not be as straightforward, and that presents interesting challenges as well. So Why is this an important problem? And why should we as marketers care about polarization in COVID vaccine discussions? Well, first, it poses challenges to managers to influence consumers' perception, their attitudes, and their choices of vaccines. So, in addition to that, it also poses challenges to managers of other vaccines and for regular routine immunizations, such as for children. And it also poses challenges to managers of adjacent industries such as pharmaceuticals. Right. So polarization in COVID vaccine discussions is an important problem to study. And with that as the motivation, I'm just going to give us a brief overview of our research questions and what we find in as short answers, and we'll go through them in detail in this talk. So our first question is, we study, did COVID change vaccine attitudes? So we use causal inference to understand how did COVID change vaccine attitudes. We find that there is increased pro-vaccine and anti-vaccine tweets. So there is increased engagement with vaccine, and there is more pro-vaccine discussions with positive announcements. The second question that we explore is, did vaccine discussions get more politically polarized with COVID? Here we find that there is a shift towards more pro-vaccine, and the engagement is coming from more from users who are apolitical, right? So this becomes a less fractured market. And we also find that vaccine tweets got less toxic. Third, we explore if differences in political identity result in differences in vaccine support. And here we find consolidation in vaccine stance towards more pro-vax, and right users shifted towards more pro-vax. And finally, we explore how did good and bad news affect vaccine discussions. So in our data, there are two major announcements: positive news of Pfizer vaccine efficacy. Here we find higher response for the right inclination users. The bad news of J&J, which was a vaccine that was paused in April 2021, we find it's a missed opportunity to highlight that the science is working. So our contribution substantively is we explore polarization in a relevant life and death situation, and we conduct a systematic analysis of all vaccines discussions before and during COVID to estimate the nature of this change. Methodologically, we extend transformer models with user metadata to estimate vaccine stance in tweets. And we use causal inference to estimate causal effects with other topics discussed in text as controls. So here's the roadmap of the talk. I'm first going to walk us through the data, followed by how we extract measures from text. And then we will move on to the two broad questions, which is, did vaccines discussions get polarized? And how did vaccine announcements affect polarization? So I'd like to take a moment to ask Anuj if there are any questions in the chat, or if I'm good to move on.
Yeah, I don't see any question as of now.
Okay.
So we can
All
continue.
right. All right. Thank you. So the data that we have is we collect all vaccine-related tweets on Twitter between the time period of January 2019 through December 2020. Here we find that about 4.8 million users posted about vaccine on Twitter. It's about 23.6 million tweets, 94% of them in English. So from this universe of vaccine tweets, we identify users who posted about vaccines at least twice. And then we construct a random sample of 10,000 users to collect all their activity on Twitter, whether it be vaccine related or non-vaccine related, for the time period of January 2019 through June 2021. So for these set of 10,000 users that we identified, we collect their activities, focal activities such as tweets, the replies that they make, the quotes, their quote tweets, what are the retweets and what are they liking. And then we also observe their engagement, which is what tweets are they replying to, what are the kind of retweets that they're making, and what are the other tweets that they're liking, right? So just to get a sense of what's the representativeness of this sample of 10,000 users, on the x-axis is the dates, and on the y-axis is the volume of tweets that are vaccine related. So the red plot is our sample of the 10,000 users, and the blue plot, the blue line is the vaccine discussion in total, right? So here we find that our sample of 10,000 users closely follows the overall vaccine discussion, and that gives us confidence that the nature of vaccine discussion that we are capturing from the sample of users is similar to that on Twitter, right? Additionally, we also find that over time, there is a sustained increase in vaccine conversation, and we'll get to statistical estimates of this increase as we get through the results, right? So the next step is classifying users' political inclinations. So remember, we have 10,000 users. We now observe the tweets that they're making. So we can use that data to see what kinds of news that they are referring to in their tweets, and use that as the information to classify users as more Democrat or left-leaning, or Republican or right-leaning, or in the middle, which is apolitical, based on the all sides media data set, which has classified news across the political spectrum. So news such as CNN and the New York Times is classified as left, and the news such as Fox News is classified on the right. This data set has been used in other studies as well to measure ideological biases and diversity in media. Right? So for our set of users, we classify them into left, apolitical, and right. And for their vaccine tweets, we can then make predictions for whether it's a pro-vaccine tweet or an anti-vaccine tweet, right? So these are the following measures that we have for our set of data. First, as I just mentioned, is the political inclination, which we get from at the user level using the all sides media data. Then to construct sentiment, to construct vaccine inclination at the tweet level, we develop our own custom transformer model, which I'll get to in the method section. At the tweet level, we additionally see what are the topics that are being discussed. So for that, we use a clustering approach with representations obtained from transformers, right? Another two measures that we obtain, which in the interest of time, I'll not be able to go over in today's talk, is the tweet content of whether it's an opinion or verifiable fact in the tweet, and whether it's what's the level of toxicity in the tweet, right? So we'll focus on the first three and go from there. So in order to detect pro and anti-vaccine stance in tweets, there are a couple of approaches that have been used in the literature. These have included domain knowledge and our expert knowledge and usage of keywords to text annotation, and also using the valence of the text in a deterministic framework. There have also been predictive models that have been used, like convolutional neural networks and transformer models. The way we approach this classification task is to enhance transformers and using information about the users who are making these tweets. Can that be useful to predict the vaccine stance in a vaccine tweet, right? So just a brief overview on what is a transformer, or specifically what is a bi-directional encoder representation from transformers. Transformer, we can think of them as language models that essentially learn representations of words in text to perform language tasks such as next sentence prediction. So, for example, given a sentence in a passage, can we predict the next sentence? Uh, another such similar language task is Mast language modeling. So that is also shown here in this figure, which says, consider a sequence of 5 words, W1 through W5. If we hold out a word at random from the model, can it predict what is that word, right? So in this case, it's W4. The model is going to learn representations of words such that it can predict words that have been held out at random, right? So this is the Mast language modeling task uh, that is used to train birds, right? So birds are state of the art in bird-based models are state of the art in language processing. And the way we use this in our context is to develop a custom bird. So essentially, what we do is we enhance the representations that are learned from the bird model. So that's this piece here on the right? So we use, using the text data, we obtain the embeddings. And then we also, in parallel, obtain representations for the user level political orientation data, right? So the idea is that, can this information be useful in predicting the stance in a tweet, right? So we concatenate both these representations from bird and this user metadata to be able to predict what's the vaccine stance in a given vaccine tweet, right? So we implement this methodology in PyTorch, and we train the model on 5,683 tweets that have been annotated as either pro-vaccine or anti-vaccine. And we note that while we use here the transformer model, this is extendable to a general class of transformer models as well, right? So with this, we are able to achieve improvement in F1 performance by 2 basis points. And to just give you a sense of how this model performs in stance classification, here's a short snippet of tweets around November 9, 2020. So that's when Pfizer announced the efficacy of its vaccine, the phase 3 trials, right? And the vaccines looked like a real possibility at that point of time. So we use the model to classify by for the vaccine stance of pro-vaccine and anti-vaccine. And we look at that for each of the user groups on the left, right, and the apoliticals, right? So we see the pro-vaccine discussions have mentions of vaccine effectiveness on the left, and the apolitical on the right, it is that they're nearing an approved vaccine. On the anti-vaccine discussions, we see discussions like we don't know if the vaccine is even going to work. It's Monday morning after the election, and will I be getting the Bill Gates vaccine? Right? So we see that our model is able to predict these tweets, the vaccine stance in them with a high face validity, and we proceed to score the vaccine tweets that we have using this classifier, right? So having classified tweets as pro-vaccine and anti-vaccine, and with our set of users, which are classified as either left-leaning or right-leaning or apoliticals, we now wish to study how did discussion of vaccines change with COVID and with Vax News, right? So an issue that we have is that this is a national shock, right? There is no geographic or timing variation specific to vaccine discussions. So in order to overcome that limitation, what we propose is we take the tweets of our sample of users and we estimate the topics that are discussed in those tweets, and we use all non-COVID, non-political topics to construct a control for vaccine discussions, right? So remember, we wish to estimate how did vaccine discussion change. We need a counterfactual for that. To construct that, we use non-political, non-COVID topics from our sample of 10,000 users tweets, right? So it's important to note that some of these topics might be correlated with vaccines. So for example, sports discussions could go up. So we view these as conservative estimates. In terms of estimation strategy to construct controls, we use generalized synthetic controls and Bayesian synthetic controls to construct counterfactuals. So essentially what this allows us to do is construct appropriate control for vaccine discussions. And this uses, in the generalized synthetic controls, we use latent factors with cross-validation to account for unobservables in the data. In the Bayesian synthetic control framework, we use regularizing priors, such as horseshoe, to select control units, right? So we also test this with other specifications. So for example, Bayesian time series models, right? So these model latent processes specific to treatment group, and we find directionally similar results even with alternative model specifications. Right. So how do we estimate topics in tweets, right? So remember, we have 10,000 users. We observe all their tweets. We can use that information to quantify what are the topics that are being discussed in tweets, right? So remember that tweets are short texts, right? These typically are limited by, for example, 140 characters. So traditional approaches such as latent dirichlet allocation and topic models tend to struggle with shorter texts. So instead, what we propose is a two-step process, right? So if I just explain this in a bit, what we do is we take our tweets and obtain transformer-based representations for these tweets, and we project them into a lower dimensional space using uniform manifold approximation and projection, right? So tweet embeddings are typically 768 dimensional embeddings. In order to be able to efficiently cluster them, we need to bring them down to a lower dimension. And what this UMAP, or uniform manifold approximation and projection, does is it constructs a lower dimensional space which preserves the topological properties of the higher dimensional space, the 768 dimensional space, and in a manner that the cross entropy between the two spaces is minimized, right? So essentially what this does is it takes the 768 dimensional tweet embeddings, projects them into a smaller space, and then we apply hierarchical density-based spatial clustering, right? So this is a clustering technique. Essentially what this does is the authors of HDB scan argue is that we want to be able to find clusters of coherent topics amongst a sea of noise, right? So you want to find islands of coherent points in a sea of noise. So remember, we're working with tweets data, and the discussion in the tweets tends to be scattered. So we want to be able to estimate topics in these tweets. And essentially, when we apply this procedure, what we find is, so for example, the topics that I have here on the right, these are around the shorter window of the Pfizer announcement. So here we find discussions such as those around sports and food, video games, for example, and gender. And there are about 100 more topics around that time window. So we use discussions of these topics to construct a control for our vaccine discussion, right? So we want to measure how did vaccine discussion change. For the control, we go back to these topics to construct a control.
Piyush, can we take a few questions?
Yeah, please.
So there are few questions here.
Mhm.
Where did they go? Sorry, I'm just trying to, yeah. One is that how did you identify people talking about vaccines? Did you do hashtag study or did you just
Yes,
directly analyze the text?
right. So yeah, uh, to clarify that, yes, we looked at commonly used hashtags around vaccines. So these are hashtags that we identified, like vaccine, anti-vaccine, vaccination. So we have a list of around 26 hashtags that we used. And wherever we see on Twitter usage of those hashtags, uh, we use that as information to identify vaccine discussions on Twitter. Yes.
Okay. There's one more question which I got direct DMs here. One is that
Mhm,
your assumption here is that if people are tagging CNN, that means they are more left wing. But
mhm.
isn't it possible for certain users that they tag opposite news channels to make a point? How will you account for that?
Um, right. So so essentially what you're saying is when we classify users based on their uh, media usage, right?
Right.
So the idea is that the idea that we have here is that usage of these directly in their tweets is indicative of their political inclination. So if users are using more of the left uh, news than of the right, that is the information that we use to classify users into uh, to classify users into political inclinations, right? So
Yeah.
can you repeat the question again? Sorry, I.
The other question was that if someone is quoting CNN or citing CNN
Mhm,
in their tweet, there is also a
mhm,
possibility that they are actually right wing who watch Fox News, but they're just
mhm,
trying to bring CNN to their tweet to bring forward a point which is
mhm.
actually anti CNN, but they are just
Yeah,
using CNN to make
exactly.
their point, right?
Right. So in separate analysis, I'm not, I didn't add these to the slides here, but in separate analysis, we do look at the kinds of tweets that they are engaging with these users, and we find uh, that we find similar effects there, right? So essentially, that gets at uh, what we are finding for these users is along their political lines. Yeah. So yeah, that's a valid point, right? Yeah.
Right. There are a few more questions. One
Hmm.
is, are you using discrete ways of classification of
Hmm.
these tweets rather than a continuous score? Like, for example,
Hmm.
you are saying, uh, I think you had neutral,
Hmm.
anti-vaccine, pro-vaccine, or are you using to classify people into left and right wing continuous score?
So let me go back to that slide here, right? So the vaccine sentiment is classified as pro-vaccine or anti-vaccine in at a tweet level. So that's a binary classification. Users are classified. The political orientation is at the user level, right? So that is less to do with the tweet, and it's about the user. So that again is in a three-way classification task. It's left, right, or apolitical.
Right, right. There are two more questions which I'm not able
Mm,
to understand. I think he's trying to mention that okay, uh, I think with dynamic LDA they are trying to say that, for example, when you see reviews on Amazon over a product life cycle, sometimes people initially are talking about more functional attributes, but then they move
mm,
into more experiential attributes. I think
mhm,
Kinshuk also has a paper on that.
mhm.
But do you account for the temporal linkages between how the reviews change and vis-a-vis the political orientation of an individual also changes, or if it's not a complete flip, it changes uh, a bit.
Mhm,
Sometimes you are more left leaning, or on some topics you are more left leaning, but
mhm.
probably not for others. I think that's what they're trying to say.
Yeah. So 2 points here to make, which is one is tweets are fairly small, right? So
Okay.
they typically tend to have just one topic of discussion in the tweet, so there's no time variation at the tweet level, right? At the user level, what we account for is we look at their political inclination uh, as a static measure, right? So we look at their political inclination prior to the announcement, and we use that as the variation. So you're right, a user can be left for vaccine, but for other topics they can be different, right? But our interest is in around vaccine discussions. Uh, how did that change with political inclination, right?
Right. I think there's one last question. Isn't
Mhm.
there a heavy mismatch in pre and post treatment durations?
Mm. So we'll get to this in a bit. Essentially, we look at a longer time period of treatment, which is COVID on January 7, 2020, when CDC announced a response. Uh, COVID CDC set up a COVID response team, right? So we also look at shorter time windows around Pfizer and J&J that are uh, 30 days pre and 7 days post. It's more crisp identification. That allows us to say that we're finding similar effects. So it's not an artifact of the length of the treatment duration, right? So I'll get to that. I think that's a few slides ahead.
Right. I think we don't have any more questions. Thank you.
Okay.
Yeah.
Right. So with these topics that we estimated um, from the tweets as the controls, we then go to our research questions, which is the first one, which is how did vaccine attitudes change with COVID? Right. So just to give us uh, the vaccine tweet trends over time. So here the x-axis is the weeks relative to the CDC COVID announcement. So that's set as 0. On the y-axis is the vaccine tweets, and the two lines represent pro-vaccine tweets and anti-vaccine tweets over time. So here we find that there is increased engagement with vaccine. So there is increased tweets for both pro-vax and anti-vax, and it seems like there's a larger overall increase for pro-vax. Right? So if you look at just the shares of pro-vaccine and anti-vaccine tweets over time, so prior to 2020, it was about 67% pro-vaccine on Twitter in our data. With COVID, it fluctuated a bit. Anti-vax went up to about 39%. But after the Pfizer announcement, that is where we see increase in pro-vaccine with Pfizer and the more positive news that came out subsequently, such as the FDA emergency use authorization and so on. Right. So to get at causal estimates of this increase in pro-vaccine discussions, remember we have topics in tweets, and we use those as controls to identify counterfactuals for both pro-vaccine and anti-vaccine, right? So if you notice uh, up until the Pfizer announcement, both pro-vaccine and anti-vaccine discussions were following similar increments compared to their respective counterfactuals, right? So the y-axis is how much compared to their respective counterfactual are they high or low, right? It's around this time window that we see that they start to diverge, where we see larger pro-vaccine response compared to anti-vaccine response, right? So we can also view this by political groups, and in order to look at in order to look at this comparatively, what we do is we used 2019 means, right? So what was the level of discussion of pro-vaccine tweets across the political spectrum of users, right, apolitical, and left, and we plot that over time, and we see here that it's around the weeks 10 through 20 when different states in the US started announcing lockdowns. There were different COVID policies. this is where we started seeing an uptick in pro-vaccine tweets. What's encouraging for regulators is that there's uh, it's higher for apoliticals and right users, right? So compared to their 2019 levels, they seem to be engaging more in those in that time window. Right. On the anti-vaccine side, we do a similar exercise. What we find is, again, there is an uptick in around weeks 10 through 20. And this is from more of apoliticals, right? So what's encouraging to regulators is that the anti-vax increase is coming from more centrist, right? So, and we'll get to why this is encouraging. We also find that apoliticals use more verifiable facts, and these tweets are less toxic. So uh, these are encouraging findings for regulators, right? So to summarize, did COVID change vaccine attitudes? We find there's a larger increase in pro-vaccine tweets from apoliticals and right users. And it seems apoliticals are contributing more to anti-vax discussions. What the generalized synthetic controls allows us to see is, in a causal manner, uh, what was this change? And we find that pro-vaccine responded higher to positive news. So these findings are reassuring to regulators that there is an increase in pro-vaccine. Right. So the next question we explore is, did vaccine discussions get more polarized with COVID? Right. So to do this, we extend on the previous analysis, and here what we do is we look at the share of voice across the different political ideologies. So left, apolitical, and right in the pro-vaccine tweets. Right. So on the x-axis, again, is the weeks with respect to COVID announcement. On the y-axis is the share of vaccines, share of pro-vaccine tweets from each of these user segments. Right. So again, we find here that there is a shift in the share of pro-vaccine discussion, which prior to COVID was largely from left. Right. So in the weeks 10 through 20, the apoliticals have seems to have picked up, and this shift in political participation from apoliticals seems to persist over time, right? So there are larger engagements, and these shifts tend to persist after, right? On the anti-vaccine side, we find similar evidence, and interestingly, what we find is right users' share of discussion on anti-vaccine, which was considerably higher prior to COVID, that seems to have gone down. And again, it seems during those 10 weeks of mid-March to May 31st, that's where apoliticals picked up the share, and this again seems to have persisted over time, right? So what we find is that the apolitical share has increased across vaccine discussions, both pro-vaccine and anti-vaccine. And this happens fairly early. It happens in weeks 10 and 20 after COVID. In fact, these shifts persist over time. And we also find in separate analysis that vaccine tweets got less toxic over time. And what's encouraging for regulators is that anti-vaccine share on the right has declined over time. So the next question that we study is, are there differences in political identity, and do these lead to differences in increased vaccine support, right? So bear with me for a minute while I explain this graph, right? So we consolidate, we group the time into three major buckets, right? So 2019, that's prior to COVID, January through October 2020, that's the second time window. And then the third time window is November 2020 and later. That's when we saw a lot of positive announcements come for vaccines. And so The bar plots, the blue ones are for pro-vaccine and the red is for anti-vaccine. So first one is 2019, then the second is January to October 2020, and the third is November 2020 and onwards, right? So we find that there is consolidation of vaccine inclination, right? So overall, it tends to go more pro-vaccine across the three major time windows. Interestingly, what we find is that if you look at right users, uh, in the prior time periods, in fact, up until October 2020, they were more anti-vax, right? So the proportion of anti-vax tweets was substantially higher than pro-vaccine tweets on the right. And November 2020 and later, that's when we see this flip. The right users become more pro-vaccine, right? So to understand drivers of this change uh, and this consolidation of views over time, we turn to causal estimates from the generalized synthetic controls. So here we compare for each of the segments, the user segments of left, right, and apolitical. Walk us through those. How did they respond uh, with the announcement, right, over time? So here, what we find is similar. Here, what we find is evidence that up until the Pfizer announcement, the pro-vaccine and anti-vaccine voice was responding in a similar manner, incrementally, right? So compared to its counterfactual. But after the Pfizer announcement, we find that there's a large delta between pro-vaccine and anti-vaccine tweets response for the left users, right? Uh, uh, for apolitical users, we conduct the same analysis, and again, we find similar evidence that it's with these positive announcements that the pro-vaccines really responded more as compared to anti-vaccines. And again, same for the right. The right users which flipped to pro-vaccine, they responded uh, much higher after the positive announcements, right? So that's where we see the pro and anti-vaccine tweets respond differentially. So to summarize, did differences in political identity result in difference in increased vaccine support? Yes. Uh, we find consolidation in vaccine stance towards more pro-vaccine, and then right users changed to more pro-vaccine. Right. So now, the last question that we study is, how did good and bad news affect discussion of vaccines? Right. So now we're going to look at specific events and vaccine news. So vaccine news, when these news were announced, they served as new information to the public. And we look at both favorable and unfavorable news. And what this vaccine news serves purpose for is it serves as a lightning rod for opposing viewpoint. And it's also, why it's relevant is it makes it harder for policymakers and firms to change opinion. So it's important to study this relationship between the vaccine news and polarization, because it can offer insights to managers on how to manage and influence conversation, customer conversation on vaccines, and also for regulators, especially given the short time frame, right? So there is an opportunity and an urgency that can they manage influence conversation, right? So we look at two events in a very short time window. The first one is the Pfizer announcement on November 9, 2020, when they announced the efficacy of the Pfizer vaccine. We look at 30 days prior to the vaccine announcement and 7 days after. So this is a short time window that allows us to measure how did this news change discussion of pro-vaccine and anti-vaccine. And we see this as a megaphone effect. How much did our users speak up across political inclinations? So here again, we find that compared to their respective counterfactuals, pro-vaccine tweets increased more in the post period, both in terms of percentages. So at its peak, a 12x increase compared to an 8x for anti-vaccine, and also in terms of volume, right? So next we explore what were the shares of pro and anti-vaccine in this short time window for the left users and the right users across the political spectrum for pro-vaccine and anti-vaccine. Right. So we see here that users posted more pro-vaccine. The shares for pro-vaccine grew, and this is true across the spectrum. And here again, we find that right users switched to more pro-vaccine, right? So 49% to almost 60%. So that's a 21% increase in share. And if we just look at the increase in tweet volumes for each of these segments, we find that there is a stronger pro-vaccine response compared to anti-vaccine for the right. So this difference is stark, and there is a greater increase in pro-vaccine overall as well. Right. So we do a bunch of robustness for these effects. We look at we conduct placebo tests. So the first one is placebo time to rule out the alternative hypothesis that whether it's a time-induced. These estimates are from that. So what we do is we move the treatment days 7 days prior. So essentially, what would happen if we instead of November 9, if we assume November 2nd as the announcement date, right? So we want to look at there's no difference in discussion, and that's what we find null effects that moving the treatment date 7 days prior did not see effects for that. The other placebo that we conduct is at the unit level. So essentially, to be able to say, if instead of vaccine, we pick 5 other topics at random, were there other things happening in the discussion other than vaccine in that time window, right? So what this allows us to rule out is that if there are other effects in our data at the unit level, right? So here we take 5 random control topics and consider them, assume them as being treated as if they had an announcement around November 9. And again, we find null effects here, which gives us confidence in our estimates that these are actually robust estimates around the Pfizer vaccine announcements, right? So the second event that we study is in April 13, 2021. This is when J&J vaccine was paused. It was found that there were instances of blood clots from this vaccine, and so it was paused for a while. So we conduct a similar analysis here compared to April 13, 2021, 30 days pre, 7 days post. And again, similar placebo tests as the last event analysis. And here we find that there is a slight increase in anti-vax discussion on the day of the announcement. But more broadly, there is no change in vaccine discussion from this announcement, right? So vaccine discussions didn't change as much. And we see this as a missed opportunity to highlight that science is working in this event, right? So to summarize, how did good and bad news affect discussion of vaccines? For the Pfizer announcement, which was good news of the vaccine efficacy, we find higher response for pro-vaccine across the political spectrum, and this is we find the highest increase in for the right users. So that is encouraging for regulators. On the bad news, the J&J vaccine pause, we don't find changes in vaccine discussion, and we view this as a missed opportunity to highlight the process of science working. So with this, what are the conclusions of our findings? For managers, we note that consumers responded favorably to positive news of vaccine, right? And if you think about messaging on the political spectrum, apoliticals may be a possible group to pursue, as studies have shown being exposed to different views of opposite political spectrum makes you more dug in. For regulators, what we find is that there is evidence of vaccine consolidation towards more pro-vaccine. This is true across the political spectrum. There is increased share of apoliticals in vaccine discourse, which is encouraging, right? And for on the news, on the event news events, we find for positive news, it's Twitter can serve as a point of influence or a megaphone for pro-vaccine, and that polarization is in a favorable direction from perspective of policymakers. On the negative news, we find that it's a lost opportunity for pro-vax to say science is working as it should to keep vaccines safe and effective. Now, one concern we share with other studies that study social media data is, in our context here, is if anti-vaccine voices are being driven underground or elsewhere. So, for example, to Parler or Reddit. But with that, these are our implications and findings, right? So that's all I had for now. Anuj, if there are any questions, I can take them.
Yes, please. Thanks, Piyush. I see one question. Are there more questions? Yeah, I'm just trying to see. I had seen one question here. Yeah, I think we don't have any more questions.
Okay.
Piyush, thank you so very much once again for
Yeah.
sharing. This is, I'm assuming, not even the working paper is probably not available yet, so it's very uh, new and current, right? The
Yeah.
research.
This has been great. Thanks, Anuj. Yeah.
Yeah. Thank you so very much, Piyush, once again.
Yeah. Thank you.
Thank you.
Thank you.
Bye-bye. Thank you.